Inshallah, in this class we are going to do problems based on the even functions and odd functions. See, whenever the interval is given between minus pi to pi, first thing, interval is given between minus pi to pi. Let me see whether the function is even or odd. In the previous classes, we already seen if f of minus x equals to plus f of x, then we say this is even function. If f of x minus x equals to plus f of x, we say this is even function. If f of minus x equals to minus f of x, we say this is odd functions. We already seen this concept in the previous classes. Now, if we see for the only for the interval between minus pi to pi, not for 0 to 2 pi, not for 0 to 2 pi. If we have the interval between minus pi to pi, let we see the function whether it is even or odd. Suppose if the even function, if it is even function, we already seen what is the formula of this is in the previous class. Fourier series is a naught by 2 plus sigma n equals to 1 to infinity a n cos nx plus sigma n equals to 1 to infinity b n sin nx. We have to find a naught, a n and b n. Then we have to substitute in this formula. But if the function f of x is even, we don't have to find bn. Bn will be 0. Bn will be 0. If for the interval minus pi to pi, if f of x is even, then formula for a naught is 2 pi 2 divided by pi 0 to pi f of x dx, and an is 2 by pi integration 0 to pi f of x cos nx dx, and we don't have to find bn. Bn will be 0. In the same way, if a f of x is odd function, if f of x is odd function, these two values will become 0. F a naught and a n become 0. We have to find only bn. So bn will be 2 by pi into integration of 0 to pi f of x sin dx and x dx. I request first you to write this all formulas on paper, revise this, by heart this, then let me do few questions. But first you by heart the formulas, let me start to do the questions. Now see the question, next question. Let me start the question. Expand f of x equals to x square as a Fourier series in minus pi to pi. Or he can ask like this, show that x square equals to pi by 3 plus 4 sigma n equals to 1 to infinity minus 1 power n cos n x by n square. From this we have to deduce this 1 by 1 square minus 1 by 2 square plus 1 by 3 square, so on. Alternate plus minus equals to pi square by square. How to start? No, just now I explained. Whenever we are having interval between minus pi to pi, let me see if the function is even or odd. If the function is either even or odd, then it will become easier. How to find? We have to see f of minus x. In place of x, you keep minus x whole square. But minus square is even plus, it will become x square. That is same f of x in x square is nothing but f of x. Therefore, we got f of minus x equals to plus f of x. That is, therefore, what is this? F of x is even function. Is even function. Therefore, just now we have seen what is a naught. This is 2 by pi integration 0 to pi f of x dx. Bn is 2 by pi, sorry, an. And we know bn is 0. So bn is 0. Let me first find a naught and an, then let me substitute this in the question. Okay, so let me start with a naught. Now see here, therefore a naught equals to 2 by pi integration 0 to pi f of x. F of x is nothing but x square dx. No, 2 by pi integration of x square is nothing but x cube by 3. Limits are 0 to pi. You see here I'm writing like this, 2 by, take out this 3 outside, 3 pi. Now upper limit minus lower limit, upper limit is pi cube, lower limit is 0, leave this 0. If you cancel this, this we left with pi square. Therefore, now we got the value of a naught. A naught is 2 pi square by 3. So this is the first step. Now let me find an. Now see on the board, just now we have seen now an is 2 by pi integration 0 to pi f of x cos nx dx. Now this is integration by parts. How to do? We have to suppose u as x square and v as cos nx. We know how to solve this. There is a formula for this. u v1 minus u dash v2 plus u double dash v3, so on. U dash u double dash are the differentiations, v1 v2 v3 are the integrations. So let me differentiate this. U dash d by dx of x square is 2x. You differentiate one more time. U double dash d by dx of x is 1, 1 into 2 is 2. If you go further it will be 0, so stop here. So we have to use up to this, because u double triple dash will be constant 0. Now come here, v1 integration of cos is sine nx, but in integrations we have to divide the coefficient of x. What is coefficient of x here? N. So we have to divide this by n. v2 again integration of cos sine is minus cos nx by again n, one already one n is here, one more n square, and v3 minus integration of cos is again sine nx by again one n into n square will be n cube. So we have to use this formula. Okay, now see here, I'm writing one more step here. So let me use a n equals to 2 by pi. Now we are integrating this one. What is the formula? U v1. U is x square into v1 is sine nx by n minus u dash. U dash is 2x. U dash is 2x into v2. V2 is this one. Again minus, you will get plus minus 1 as plus cos nx by n square plus u double dash. U double dash is 2 into v3. This is minus, so plus into minus will become minus sine nx divided by n cube. So limits are 0 to pi. 0 to pi. Let me substitute now. We have seen many times sine 0 or sine n pi is always 0. See here, a n equals. Let me substitute upper limit. Upper limit is pi. Sine n pi is 0. 0 into a number 0. Here also sine n pi is 0. So left with only cos n pi. Cos n pi we have seen many times. This is minus 1 power n. 2 into x is pi. Sine n pi is minus 1 power n by n square. Must always remember this. Sine n pi is minus 1 power n. So this is the upper limit minus lower limit. If you keep lower limit, sine 0 is 0, sine 0 is 0, cos 0 is 1, but here x is 0. So 0 into 1 is 0, all lower limit is 0. Let me cancel this, pi will get cancelled. Therefore, an equals to 2 2s of 4 into minus 1 power n by n square. And we don't have to find bn, because for even numbers, even function, bn is 0. So let me substitute all this in the Fourier series formula. Now let me substitute in the formula. F of x is x square here. So you write x square equals to a naught. The value of a naught is 2 pi square by 3. Also we are having 2 in the denominator. So you write 2 in the denominator. Plus sigma n equals to 1 to infinity. 1 to infinity. What is your an? We got the value of an as 4 into minus 4. You can write constant outside. What is left here? Minus 1 power n cos nx divided by n square. Since bn is 0, this will become 0. Leave this one. If you cancel this 2, so this is the Fourier series for the first answer. Now from this we have to derive one more thing. What we have to derive? We have to derive this 1 by 1 square minus 1 by 2 square plus 1 by 3 square minus 1 by 4 square, so on, pi square by 12. For that, let me expand this one. See here, x square equals to pi square by 3 plus 4 into, if you cube n equals to 1, this is odd. So odd power minus 1. Minus 1 per odd is minus. Cos 1x means x by 1 square. Okay. Now let me do one thing. If you substitute 2 here, minus 1 square, this will be plus. So this will become plus cos 2x by 2 square. Again, if you substitute odd 3, minus cos 3x by 3 square plus so on, you'll get series like this. So is this expansion. After that, what we have to do, watch carefully. We have to get here 1 1 1. So very easy. Put x equals to 0, because cos 0 is 1. So if you keep x equals to 0, this will become 0 equals to pi square by 3. You take minus common from here. If you take minus common, this will become plus cos 0 is 1. 1 by 1 square. Because we have taken minus common, this plus will become minus. 2 into 0 is 0, cos 0 is 1. So 1 by 2 square. Because we have taken minus common, this minus will become plus cos 0 by 3 square minus so on. Now you do one thing, bring this pi square by 3 here, it will be minus pi square by 3 equals to minus 4 into 1 by 1 square minus 1 by 2 square plus 1 by 3 square minus so on. Now this minus minus will get cancelled. If you bring 3 here, 4 here, 4 3s are 12. Therefore we got the next answer, 1 minus 1 by 1 square minus, sorry, 1 by 2 square plus 1 by 3 square minus 1 by 4 square plus so on. If you bring this 4 here, 4 3s are 12. So pi square by 12. So we got the answer, both the answers. Let me do one more question of this type. Now let me see one easy question here. Expand f of x equals to x in the interval minus pi to pi. We already understood that when we have the limits from minus pi to pi, we can see that the function is even or odd. How to see? We have to find f of minus x. In place of x, if you keep minus x, this will be minus f of x. So this is odd function. We know for odd function a naught is 0, b naught is 0, and bn is 2 by pi into integration 0 to pi f of x sin dx, sin nx dx. Now therefore the Fourier series become a naught is 0, an is 0, so left with only bn. We have to find bn. Now see how to find bn. Let me substitute this u and v integration by parts. U equals to x, v equals to sin nx. Now u dash d by dx of x is 1. Now come here, v1 integration of sin is minus cos nx by n. Again v2 minus integration of cos is sin nx by n, again n into n square. So we can write like this. What is the formula? uv equals to u v1 minus u dash v2. So let us bn equals to 2 by pi into u. U is x into v1. v1 is minus cos nx by n minus u dash is 1 into v2. Again minus means this will become plus sin nx by n square 0 to pi. Now if you substitute pi upper limit, 2 by pi minus x is pi, cos n pi we know minus 1 power n by n, sin n pi is 0, and you substitute the lower limit 0, x is 0 into a number 0, sin 0 is 0, so pi will get cancelled. So what is bn? Therefore bn equals to 2 by pi 2, sorry, pi will get cancelled, no, 2 into minus 1 power, I am writing like this, n plus 1, minus 1 power n into minus, that is minus 1 power 1, we can write like this. So minus 1 power, bases same, powers add, minus 1 power n plus 1 divided by n. So let me write therefore f of x equals to sigma n equals to 1 to infinity bn. We got the value of bn as 2 into minus 1 power n plus 1 by n into sin nx, sin nx. Okay, so let me do one thing. What is sin f of x? F of x is x. Now take out 2 outside, 2 into, let me expand this one. Let me start with, if you keep n equals to 1, minus 1 power 1 plus 1, 2 square, this will become plus sin 1x means sin x by 1. If you keep here 2, minus 1 power 2, 2 plus 1, 3, odd will become minus 1 minus 2. So we have taken 2 common, sin 2x by 2. If you keep 3, 3 plus 1, 4, this will become plus sin 3x by 3. Again it will be alter sin 4x by 4 plus so on. So this is the Fourier series of f of x equals to x in the interval minus pi to pi. So inshallah we will continue in the next class with the half range series of sine and cos inshallah. So I request the students to like, share and subscribe my channel inshallah. We are going to continue in the next class.